In this video, we'll continue our discussion of section 7.1. This is just the definition of our Laplace. We're going to do a few more examples here. So again, I'm going to write down the definition. I usually do this when I'm learning things. Like through homework, I would write this down every time. All right, that's the integral from 0 to infinity of e to the negative st times f of t dt. All right, so if we're doing the Laplace of the letter t, remember this is going to take us to s. So maybe we could write here because we're going to need to get used to that notation as well. So f of s. Okay, so if I plug this in, I'm going to go ahead and change it to the limit and go ahead and put my upper bound as the n. That way I can go ahead and work with it. And then we get t times e to the negative st dt. All right, this it calls for, I have a vanishing function, t, so this tells me that I can use my integration by parts, but use tabular, since one of them are vanishing. Okay, so this is plus minus, and then our derivative, d dt, and then our integral plus minus plus, I think that's probably all we'll need. T, my vanishing function, goes in the middle, gets me down to 0. And then I got e to the negative st. This is 1 over s e to the negative st. You can see it by taking the derivative. And then we get one more 1 over s squared e to the negative st. All right, and you can see that if you take the derivative there, you get up and then you go back all the way. Now our integration by parts, this says, okay, limit as n approaches infinity, and we can go ahead and multiply this out. I get negative 1 over s t e to the negative st, and then I'm going to get a plus, nope, it's still minus, minus 1 over s squared e to the negative st, and then we got to run t from 0 to n. All right, so the limit is still there. Okay, let's plug in n first. So it's going into t, so I'm going to get negative n over s e to the negative sn minus 1 over s squared e to the negative sn. So that's the first, and I should have put these like maybe in parentheses to keep them straight. So that was the plugging in n minus, and then we got to plug in 0, and you just got to be careful because most people are like, oh, I plug in 0, things go away. Yeah, you're right, the first term goes to 0, but this back term, e to the 0, is just 1, providing that 1 over s squared. Now, if you just look here now at our limits, this thing is definitely going to 0. I have e to the sn on bottom. Even though I have that n on top, e functions grow a lot faster, so it would take over, forcing it to 0. Same logic here. And then this just leaves our answer to be 1 over s squared. So this is a new rule for us. We're going to use it. We want to derive it again. The Laplace transform of t is equal to 1 over s squared. All right, so there's our answer for that one. All right, we're going to go ahead and do another one here using e functions on our next page. All right, so let's take a look here. We'll do one at a time. So again, I'm writing down the formula every time I do a problem. That's really bad. There we go. F of t. Writing down the formula, I mean 0 to infinity e to the negative st times f of t dt. So I memorize it over time. I'm spacing out the time between where I'm writing it down, forcing myself to maybe hopefully put it in long-term memory. Okay, so the Laplace of e to the negative 3t. All right, we'll change it to the limit to infinity, and then this is 0 to n e to the negative st times e to the negative 3t dt. All right, I'm going to combine those e's. Remember, we add. So if I had negative st minus 3t, okay, notice they both have t, and then I could also pull out a negative. So it's like s plus 3. So I'm going to rewrite this, the limit as n goes to infinity of 0 to n And then we know that this is negative e to the negative t times s plus 3 dt. Right? So taking this integral, it looks very similar to what our definition is, right? So if you look there, we have that e to some power, and then it's just like times a 1. So what we're going to actually do is do a u sub. What's really nice is we're not changing t. We're just going to change that u, or the s plus 3. So I'm going to go ahead and put it like this, s plus 3. And then this becomes our limit as n goes to infinity of 0 to n of e to the negative t times u dt. Okay, well, that is the, if I want to look at that, that is the, we could go ahead, I guess, and take our integral actually. Sorry for the stuttering there. So we have negative u. So I could keep going. This is going to be the limit as n goes to infinity, and then we're going to have negative 1 over u e to the negative t. Remember, u is just we're just dealing with the sub here, it's just a number. So that comes down, I get negative tu. You could take the derivative there and see that you'd get back to where we were. And then we're running this, remember this is t. I think it's important to put the t here so I don't mess it up. All right, so we get the limit as n it goes to infinity. And then I'm going to put this in brackets and then parentheses to keep them straight. I get negative 1 over u e to the negative n u minus negative 1 over u e to the 0. All right, well, that's the limit as n goes to infinity. And notice as this happens, that goes to 0. And this is leaving me with a positive 1 over u e. E to the 0 is gone. So this ends up being 1 over u. But remember, u is not our answer, right? So I'm going to go this way, actually, to save some room. That's 1 over u. We don't have terms of u, we want terms of s. U is just s plus 3. Okay. So we're going to go through that same kind of process, but we're going to now, just to try to verify, you might already have an idea of how to write a rule for this, maybe, if I change negative 3 at the top. But let's go ahead and confirm that. I'm going to crank this up so I have more room. Sorry if you used up that much. Trying to get better at telling you guys that. It's just kind of hard to know sometimes. Even my notes, I ended up writing more than I did in my notes. All right, so we have now the Laplace of e to the 5t. Right, we get to run through that same process. So I'm going to change it to the limit of 0 to n, e to the negative st times e to the 5t dt. This equals, all right, and we're going to get, we can put them together. So the limit as n goes to infinity, and then we got 0 to n. Remember, we add our exponents, so we're going to have 5t, or we could even go ahead and put them together. I think you guys could probably see it. We got t, and then it's going to be, let's pull out negative t, right? That's what we want. Negative t, and it's going to be s minus 5. Hold on, my brain's like breaking down here. I How do we want to do this? We need, if we're matching the definition, let's run through our thought process. I'm going to need maybe that negative out front with the t behind. Let's go ahead and just move forward. Let's see what we have. Let's pull out a, if I do a negative, I get an s minus 5. There we go. I don't know why my brain broke down so much there. Sorry, some of you guys are probably yelling at me. Um, Hopefully that makes sense. You can see it there. Okay, so now that matches our definition. This is where in the last problem we just did a u. And this is going to change then into the exact same problem, which means I'm going to get a 1 over u in the end. All right, but that means it's 1 over s minus 5. All right. Pause the video if you want to take a guess at the rule and write it down. If not, I'm going to go ahead and give that to you here. The Laplace transform of e to the kt is equal to 1 over s minus k. That's why we got that change. So there's our rule for e functions. All right, we'll do a couple more definitions. I think it's really just one more for sine, and then we're going to put our rules together and then do a piecewise, and that'll be the end of this section. There will be a table for all this, which I'll show you in a bit. In the next section, we'll go through and look at those. But these are just forming our rules to get to our Laplace.